Okay, this is calculating average atomic mass worksheet 1, and this is going to be 6, 7, and 8. So number 6 here has the isotopes of iodine. It has 3 of them. And then again, if it doesn't give you the actual mass number, so you don't get a number with all those decimals for the mass, you just take the mass number. So in this representation where you have iodine and then the 127, that's actually the mass number, but we're going to use that in this case if we don't have the more detailed number. Again, you're going to see it all sorts of different ways later on, possibly. So I went ahead and just threw all the different ways you may see your mass given to you in one of these problems. But it doesn't change the essence of the problem, which is take the mass times the percent abundance for each of the isotopes and add them all up. So here we go. We got 127 times 80 as a decimal, so 0.80, and that gives us 102. And then we have iodine 126, so 126 times 0.17, and that gives us 21.4. and then iodine 128 has a percent abundance of 3%, so it's going to be 0.03, and that gives us 3.84. Then we simply add up all of those together for a total of 127 AMU. So the weighted atomic mass of iodine is 127 atomic mass units. Okay, moving on to number 7. Let me get that clicked off of there. Okay, so here you have kind of the reverse of what we just did. Here you have all the detail. You have some really precise atomic masses of the isotopes. And you also have some really precise percent abundances with tons of decimals. But again, it doesn't really change anything. You take the mass times the percent abundance as a decimal, and then add them all up. So here we go. So you have 27.9769 times the percent abundance as a decimal, so 0.92297. And I'll try and match the numbers here, so your result is the number of numbers, so 25.8030, and then you have the isotope that's 28.9, so 28.9765 times its percent abundance of a little over 4.5%, so 0.04682, and that gives us an answer of 1.35703. And then finally you have the last isotope, 29.9738, and it is a percent abundance of 3%, so 0.0300872. Just be really careful when you shift those percentages into decimals that it's always 2 to the left. Again, that's where I see most of the errors from people that pretty much know what they're doing. And again, when you get, hold on, this gives us 0.925351. So if I add all that up together, I get a weighted atomic mass for silicon of 28.084. Oops. I have to erase. .0854 AMU. And again, if you accidentally shift those decimals the wrong way, you'll probably catch it if you remember to check that your answer falls in between the lowest and the highest isotope masses, which this one does. So one more, let's on to 8. So this is titanium. We've seen all this before, so the only thing I would point out here is that titanium has 5 different isotopes, and that doesn't make any difference. If you have more, you just keep multiplying them, mass of the isotope times the percent, and add them all together. So here we go with this last one. Don't forget about isotope notation here. So this top number is the mass number. All right, so you have 46 for titanium, 46 times 8% is its percent abundance, so 0.08. That gives you 3.68. And then you have isotope 47, which is 7.8% abundance, so 0.078. Gives you an answer here of 3.67. Then you have isotope 48, titanium 48, which has a percent abundance of 73%, so it is the brunt of the titanium atoms. So if you analyzed a big sample of titanium and you sorted it out, you'd see most of it was titanium 48. The answer here is 35.2, and then 49 times 0.055 gives you 2.7, and finally isotope 50, 0.053, so 5.3%, gives you an answer here of 2.65. I'm going to add all those together, giving me a grand total of 47.9 AMU, and that is the weighted atomic mass of titanium. So you can see I can check my answer and make sure it's between 46 and 50, and it is. So that should be correct. All right, hopefully that helps, and that is the end of this worksheet.